Hello, everyone. This is going to be a quick recording for our Unit 5 test review. Remember that for Unit 5, we are doing a lot of stuff with trig, and in order to do trig, you need to have your some kind of graphing calculator, whether that be Desmos or a TI 83 or 84 that you have at home. So remember, in order to do the work in Desmos, we need to make sure that we are in degree mode. So if you're in Desmos here, you want to click this tool button here, and you'll make sure that it's selected for degrees, okay? Make sure that it is selected for degrees. Okay, let's go ahead and get started. So it says, what is the value of x in the triangle? What is the value of x in the triangle? So we are trying to find the length of this side. Here is our angle. Remember, we also call that theta, okay? Now, we're trying to find this side over here. What we need to do from the very beginning, okay, what we need to do right from the get-go is we need to label our sides, our opposite, adjacent, and hypotenuse. We talked a lot about it in class and how the hypotenuse is always the easiest one to identify. It's that longest side, it's the slant, it's the side that is across from that 90 degrees. So this is my hypotenuse. Now the side that is away from your angle, side that is away from it there, okay, so here's our theta here, so the side that's away from it, that is our opposite. And then the side that is right next to it would be our adjacent. You have me a different color here, adjacent. Okay, so step one, label sides, done. Step two, what sides do you care about? Well, first of all, what side am I trying to find? Okay, what side am I trying to find? I'm trying to find that opposite side, right? That's one with the x. That's one I care about. And then the other side I care about is the side length that they give me, which would be this hypotenuse. So those are the two sides I care about, the opposite and the hypotenuse. Okay, I'm going to check that off. Step 2 is done. Step 3 says what trig function deals with these two sides. So what trig function deals with opposite and hypotenuse? And it's going to be this sine. Okay, so I've done step 3. I now know that, okay, I'm dealing with sine of theta is equal to opposite over hypotenuse. And now I just fill into the formula. So I have sine of theta, which is my angle measure, so 31, and that is equal to opposite, which my opposite side is x, and the hypotenuse, which is 45. Now, this is like having two, it's like having proportions there and cross multiplying, right? The easy trick here, though, is that whenever x is on top over there, all you do is multiply straight through, okay? So we're going to say x is equal to sine of 31. You want to make sure that you close those parentheses and then multiply it by 45. So let's put that over here into Desmos. Okay, we have sine of, and I forgot, 31. There we go. I can't forget it now. Sine of 31. Remember, I want to close those parentheses. Then I want to times 45. And I get 23.17. And we want to be careful that whenever on the test or quiz or whatever the problem that you're working on, it should tell you if it wants you to round to tens, hundreds, thousands, okay? But for this, we're gonna round to the hundreds. So for that, I want 2 decimals places. So I'm looking at that third place. And since that's greater than 5, it's going to bump that 7 up. So I should get 23.18. And that seems about right, because remember our hypotenuse was 45. So if we would have gotten an answer that was greater than 45, we should have been like, whoa, hold up. I know 45 is my hypotenuse. 45 is my greatest side. Okay, let's go to question 2 now. What are the values of the trig ratios for this triangle with respect to angle A? So angle A is what we're dealing with. That is my theta. And the trig ratios, that would be sine, cosine, and tangent. So the very beginning, in order to do this, we got to label our sides, right? Label our sides over and over. So that longest side, that's going to be my hypotenuse. Okay. The side that is furthest away from my angle. That's going to be my opposite. And the side right next to it, that will be my adjacent. Now, let's plug in what we know, okay? Plug in what we know. For sine, it's O over H, right? My O is 12 and my H is 37. So there's sine. Cosine is A over H. A is my adjacent side, right? So over here, my adjacent, that's 35. So it'll be 35. And my hypotenuse will be 37. And the last one, tangent, is O over A. My opposite is 12, and my adjacent is 35. There we go. Okay, question 3. What is the value of x in this triangle? Now, here's my x. Now, the funky thing there is we're trying to find the angle, right? We're trying to find theta. And we still use sine, cosine, tangent, but when we're trying to find the angle, we're going to use the inverse buttons, okay? So let's see if the steps are still the same. Label the sides. Okay, so if that's my theta, here's my hypotenuse. The side that is away from it, way over there, that's my opposite. And the side right next to it is my adjacent. Okay, step 1 is done. Labeling those sides. Step 2, what 2 sides do I care about? Okay, I'm not trying to solve for a side. I'm trying to solve for an angle, right? So the 2 sides we care about in this case, we need the measure of 2 sides. In order to find the measure of an angle, we have to have the 2 sides. So the 2 sides they give us are that 17 and that 14. So that tells me that I care about opposite and adjacent. So then I said, okay, what trig function deals with opposite and adjacent? And that's this guy here, that's tangent, okay? So I'm going to be using tangent. So I have tangent of theta is equal to O over A. Now fill it in. So tangent of theta, now we don't know theta, okay? We're gonna put an X here, we don't know it, okay? Our opposite is 17 and our adjacent is 42. Now, like I said, when we're trying to find those angle measures, we use the inverse buttons, okay? So X is going to be equal to tangent inverse of 17 over 42. Let's go find that. I'm going to go over here. And again, Desmos does that work for us, which is great, okay? So we go to functions, tangent inverse. We're doing 17 divided by 42. There it is, 22.036. Okay, and again, we're going to round to the hundredths, okay? So we want 2 decimals. We look at that 6. It's more than 5, so it's going to bump it up, right? So that angle is going to be 22.04 degrees. Okay. Let's go to question 4. What is the measure of angle T in the triangle? Now, since we're given all 3 sides, we can use any trig function we want, really, okay? So we want to find the measure of angle T here. We want to find this theta right there, okay? So you could, let's go ahead and label our sides because you know I want you to do that. So here's our hypotenuse. This is our adjacent. And then the last one is the opposite, okay? We already used tangent inverse, so let's go ahead and let's work with, let's do sine inverse, okay? And like I said, you're given all 3 sides, so you can pick whatever trig function you want. So I have sine of theta is equal to O over H. So I don't know theta, so that's my X. My opposite is 65, and my hypotenuse is 97. So again, when I'm trying to find that angle measure, I'm going to use that inverse button. So X is going to be equal to sine inverse of 65 over 97. Let's go over here and plug it into Desmos. So I'm going to do sine inverse. I'm going to say 65 divided by 97. Should be 42.075. There we go. So that angle is 42.08 degrees. Okay, let's go take a look at question 5. From the top of a 120-foot high tower, an air traffic control observes an airplane on the runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? Round your answer to the nearest tenth. Okay, so that's big right there, right? We want to round it to the nearest tenth. Now, it says an angle of depression. So like whenever you're looking at this tower and you go down, that is the angle of depression. So it's 19 degrees. One thing that we need to remember is, remember when we talked about our parallel lines that are cut by a transversal, right here, cut by that transversal? Our alternate interior angles are going to be congruent to each other. So if this one's 19 degrees, this one is going to be 19 degrees. Okay, now we're ready to set up, right? We're ready to set this problem up. We have our theta there, 19 degrees. We got to label our sides, right? That's our first step. Here's our hypotenuse, the side that is away from our angle. That's going to be our opposite. And then the side right next to it is our adjacent. We got our sides labeled. What two sides do you care about? Well, the side that I need to find, which is this adjacent side, and the side that I'm given, which is this 120, my opposite. So I care about opposite and adjacent, okay? So what trig function deals with opposite and adjacent? Tangent. Okay, now, I know I'm going to be using tangent of theta is equal to O over A. Now, previously in the last two examples, we did not know our angle, but now we do, right? So we're going to plug that in. So we have tangent of 19 is equal to O, so our opposite, and that's 120, over A, which is our X. Okay, so one of our examples that we've had, X was at the top. X was at the top. Now X is at the bottom. So I need you to think about if we had those proportions and we were to cross multiply, right? Cross multiply, we would have X times tangent of 19 is equal to 120 times 1. So if we're trying to get X by itself, we need to divide by tangent of 19. And what we cross that out, right? And what you do to one side, you've got to do to the other. So X is going to be equal to 120 divided by tangent of 19. Let's plug that sucker in. Okay. So we have 20 divided by tangent. Oh, it wasn't 20, was it? It was 120, right? 120 divided by tangent of 19. Let me go ahead and make sure I got 120 divided by tangent of 19. Okay, good. And so I get 348.505. Okay. So we want to do this to the nearest tenth, right? So we look at those, or really what we're looking at, the tenth is just one decimal. So we look at that second number. Oh, it's a 0. So that's not going to do anything, right? So our side is going to be 348.5. Okay. Next question. What is the exact value of cosine of 30? Okay, so we've got this. You have cosine of 30. That means that you have an angle, you have a special right triangle, right? Of 30, 60, 90. Okay, now, cosine of 30. Cosine of 30. So this is my angle. So here's what I'm dealing with, right? Okay, now let's think about this. What is cosine? I had to think. Oh, look, I did. I was like, I think I have some notes. Yes, the steps. First one. First, draw a 30, 60, 90 triangle. Okay. We have this, we can use this one right here. Okay. But on your test, you're not going to have one. Okay, so you need to draw yourself one. Know that 30 opens up to x, right? And 60 opens up to the x squared root of 3, and then 90 opens up to 2x, okay? Now, we want to use the diagram to find cosine of 30. Now, cosine is a over h, right? A over h. So what we need to do is we need to label our sides. We know that this guy is the hypotenuse, okay? If we're thinking about, or if 30 is our degrees, or 30 is our angle, the side that's away from it, that's going to be my opposite, right? And the one right next to it is going to be my adjacent. So cosine is a over h. So my a is x square root of 3, okay? And my hypotenuse is 2x. Okay, since you have an x on top and bottom, they're just going to cancel out. So it's what we have is square root of 3 over 2. And this is okay. Remember we talked about this in class? You can't have a radical, or that square root sign, you can't have it on the bottom, but you can have it in the top, the numerator, okay? Okay, what is the exact value of x? Okay, here's a few things here, okay? This is a 90-degree angle. You got your 60 and you got your 30. Now, the math teacher in me would be like, yes, use your 30, 60, 90. Try your 30, 60, 90 ratios. But I've also had students in the past who they prefer trig. They prefer the sine, cosine, tangent. That is totally fine. You can do the trig or you can do the special right triangle ratios. Now, the problem though is that it's going to say exact value. So exact value is you're going to want to leave that radical sign in there if it has one. And your answer choices might not have a radical sign, so you're going to have to solve for those just in case, okay? Or just heads up there. If it says exact value, be mindful that it might have your answer choices might have a radical in them. Okay. So, let's see here. What side do they give us? Okay, they give us this 20, and that side, it's the 90 that opens up to them, right? Okay, so we're going to, underneath that 90 degrees, that hypotenuse, we're going to put 20. So we're going to use this to figure out what x is, okay? So let's see, 2x is equal to 20. I'll divide both sides by 2, so x is equal to 10. So everywhere I see an x, like right here at the beginning, it'll be 10. The next one, 10 square root of 3. So what's the exact value of x? Now I want you to be mindful. I need you to watch out here though, okay? Because in our picture, x is right here. This leg, okay? And that is the 60. See that? Okay, the 60. So the correct answer should be 10 square root of 3. And then the short leg, or the short leg over there, that would be 10. So since our ratio, since we use x squared of 3, 2x, you could even name this, I mean, shoot, you could name it Bob if you wanted to. Okay? Just know it's the x in the problem is not the same as the x in the ratios. Okay. Here's another one. Find the exact value of x. Okay. So this one is here's my 90 degrees. We got a 45, and here's another 45. Okay, I'm trying to find this side right here, which is the hypotenuse, right? Hypotenuse. So what side do they give me? The 5 square root of 2? And that's one of the, it's across from the 45, right? So when our angles are the same, that means that these legs, they are going to be the same. Okay, so underneath this 45, it'd be 5 square root of 2. So that tells me that x is 5 square root of 2. So this is 5 square root of 2. Now be careful here, okay? For this x, I'm plugging in a 5 square root of 2. But you also have this square root of 2 right here. Okay, So you're going to have to multiply it by another square root of 2. Now remember, we talked about this. When you have square root of 2 times square root of 2, that's square root of 4, which simplifies down to 2. So it's like they cancel the radical signs, okay? So what we're left with is we have this 5. So 5 times 2, which is 10. So this hypotenuse is 10. Okay. What is cosine A for this triangle? Okay. The A part is telling me that I am dealing with this angle right here. That's going to be my theta. Okay. I need to, cosine is going to be adjacent over hypotenuse. So what I need to do is I need to label those sides. Here's my hypotenuse, that longest side. My theta, the side that's away from it, that's my opposite. The side next to it is my adjacent. Now, cosine is A over H, right? Adjacent over hypotenuse. So how much is my adjacent side? My adjacent side is 20. And my hypotenuse is 101. That's it. That is all you do. Okay. What is tan M for this triangle? Same kind of thing. Here's my angle, or there's my theta, right? Okay. The long side's the hypotenuse. The side that's away from it is opposite. And this guy is the adjacent. Okay. Tan of M. So tangent of M. Now remember, tan, that guy is opposite over adjacent. Okay. So how much is my opposite side? Hey, it's not a number, but that's okay. It's M. And how much is my adjacent side? N. So it's M over N. Okay, a few more here. Joshua has a ladder that is 37 feet long. He wants to lean the ladder across or against a vertical wall so that the top of the ladder reaches the top of the wall. The bottom of the ladder is 12 feet from the wall. How tall is the wall? Okay. You're given one angle, it's 90 degrees. You're given two sides. You need to find that third side. Okay, so when we're given two sides of a right triangle and need to find the third, we're going to use that Pythagorean theorem. So we got a squared plus b squared equals c squared. Now, before you can do anything in that picture, I need you going and labeling your sides, okay? Just like we label hypotenuse first, we're going to do that again here, but it's C, okay? C has to be your hypotenuse. A and B, those are the legs. It doesn't matter which one you call A, and it doesn't matter which one you call B. I'm just going to say A and B here. Okay, so now we're going to plug in. A, you need to put X, or let's just leave it as A, okay? B is 12. We have to square it. And then C is 37 squared. Okay, let's go ahead and I'll leave this as A squared, but 12 squared is 144. I do remember that. Miss Harrison made me memorize those back in 6th grade, I think. But I don't know 37 squared. That is not something I'm going to put my brain cells on, right? Remember, 37 squared is like saying 37 times 37. And that is 1369. Okay. 1369. Now, because these two numbers aren't on the same side of the equal sign, we have to combine them. We have to get them together. Okay. So remember, it's like having that invisible line down. We need to get that 144 to the other side. So we're going to subtract it to get it over there. Okay, so that cancels it. Now we're left with a squared is equal to, okay, let's go back over there to decimals. Well, I guess I could do the subtraction here. 9 times 4 is 5. 6 minus 4 is 2. 3 minus 1 is 2. And then you got a 1. Okay, 12, 25. But I'm going to check myself. So 1369 minus 144. Okay, good. I got 1225. Now, I need to do the square root of that, right? So radical 1225. And I get 35. Oh, and why did I do the square root? Oh, because look here, see how it's a squared? A squared, you got to do the square root to cancel it. And what you do to one side, you got to do the other. Okay? So A is going to be 35. And that makes sense. That makes sense, right? Remember, our hypotenuse has to be that longest side. There we go. Okay, one more. In triangle ABC, the altitude CD intersects the right triangle of triangle ABC at vertex C. BD is 10.2. Okay, let's label that. So BD right here is 10.2. And AD is 7.5. What is the length of CD? This guy right here, okay? And round your final answer to the nearest 100. Okay. So we've got two triangles here because our altitude goes, it creates a right angle. It's perpendicular to this base down here. Okay, so that created a right angle here and a right angle there. See that? Okay. CD is our altitude right here. Okay. Let's call that, well, we got our green here. We can just do CD. So CD, okay? CD squared, there's a formula here. So CD squared is equal to this 7.5, which is the AD, okay, times the BD down there on the bottom. Okay, so when you have an altitude, any right triangle, when you draw that altitude in, okay, it's going to be perpendicular to the opposite side. It's going to split it into two pieces. They're not going to be equal to each other, okay, or they might be, but we can't guarantee that they are. Splits them into two, okay? We can call them X and Y here. So when you multiply those are going to be equal to the altitude squared, okay? The altitude squared. So we don't know what CD is, so we can call that, I'll take my X and Y's off here so we don't get confused there. You can call that X here because we're trying to solve for it, okay? So X squared. Now AD is 7.5. You got a times, and then our BD, which is 10.2. So when we multiply those together, 7.5 times 10.2, we get 76.5. So that means that X squared is equal to 76.5. And to get X by itself, remember we have to cancel out that squared. That cancels them out. You got to do it to this side as well. Let's see here. We got the square root of 76.5. Oops. Which gets us 8.746, okay? And wants us to round to the nearest 100. So we said 8.746. So if we went to the nearest 100, okay, we're looking at this third number there. And if it's larger than 5, it's going to bump it up, right? So it ends up being 8.75. Okay, don't forget, guys, use that geometry resource page, get those notes, get the recordings, get all the videos, get the cheat sheets, do all the things to guarantee that you have all that you need, and use those resources on your test. Okay, thanks a lot, guys. Bye-bye.